In case of usual least squares, we had a linear algebraic interpretation. That interpretation was that I am trying to minimize the residual sum of squares. I am trying to minimize the distance, the L2 distance between y and its projection. Now, ridge regression may be given a similar linear algebraic interpretation as well. So, in case of our least square thing, this was the quantity that we were minimizing, y minus x beta L2 norm square, and we are minimizing this. Now, in case of ridge regression, we can interpret it in this way. So, we are minimizing not merely this quantity, but this plus some kappa times summation beta j squared. If you do that, in that case, again you will see that you arrive at the same ridge regression. In this case, the tuning parameter will be kappa. So, if you choose a value of kappa, that corresponds to choosing a value of tau square in the Bayesian setup. That corresponds to choosing a value of lambda in the ad hoc setup. All these things are equivalent and the proofs are not very difficult. Now, observe that the condition that we are always putting here is basically that your betas should be small. In this case, I am putting this thing, that is, if beta is very large, then the summation beta j square will be large. As a result, the minimization problem will suffer. So, by putting this term, by the way, kappa is positive, by putting this term, we are trying to pull the betas towards 0. The same thing happened in case of the Bayesian thing also, where we put the condition that the betas are more or less centered around 0, because the prior said the mean was 0, and the variance tau square controlled how far from 0 we are allowing it to go. Here also it is the same idea. So, all these techniques are called shrinkage techniques. We are trying to shrink beta down towards 0, and it is this thing which keeps the variance of the estimated betas low. In case of merely least squares, there was no bound on that, so it could be very large. If there is no multicollinearity, it will not be very large, but it has the potential of becoming very large. In this case, we are always keeping a check on that. So, these techniques are called shrinkage techniques. There is yet another formulation by which we can also arrive at ridge regression, and this is like this. In this case, we are again putting a shrinkage condition. So, we are still minimizing the standard least square thing, and we are not changing this function at all. However, we are putting an additional condition subject to the distance of the betas from the origin is not too much. That is, there is some hard bound delta that we are putting, and we are saying that we are not allowing the beta summation beta j square to exceed that hard bound. So, again we have this tuning parameter delta. If we control delta, that is same as controlling kappa in the last formulation, and tau square in the Bayesian formulation, and lambda in the ad hoc formulation. So, all these things are similar. All of them are putting a shrinkage condition together with a tuning parameter. All these things are equivalent.